So far we have seen the results only for the single server queue. So you might come back and say this is too simplistic, real life hardly is something like this, because in reality queuing systems are far more complex, involving multiple stages, alternative routing of the jobs, all that. We even saw one such example in the same module a few videos before, if you may recall. In the case of that health diagnostic center, there are different ways by which the patients of 3 types were going through the system. So the question is, what are we going to do with this simple result? There are 2 important results we found. One, higher the utilization, what will happen is queue will build up. Don't go for very high utilization is one result which we found. Second result that we found is, if you reduce variability in process time, it is always better. So these 2 results are so robust that even in real life complex network of queues, multi-stage, alternate routing, reality could be quite complex. Even in such complex systems, these results hold good. Let us say we are interested in some operational performance measure. It can be the queue length. Let us put it on the y-axis. And we want to know what will happen if the utilization increases. So as this curve is showing, essentially what it says is, as we are at the lower end of this utilization trade-off, what it means is utilization obviously is very low, the service quality is good, and the cost is high because we are not really utilizing resources very well. So it is a good service, low utilization, but the cost is very high. Whereas if you go to the other end, what will happen is the utilization is high, and what it means is it is really low cost because we are able to utilize our resources very well, but service quality is poor. So these are the 2 ends to which you can theoretically push this idea. So if you come down, the quality is good, but utilization is low, the cost is quite high. If you push it to the other side, the utilization is high, cost is low, and the service is poor. So this is the fundamental trade-off that we need to make in business. As we see in this graph, both the ends are not really interesting, because you cannot afford to have a very good service which is too expensive, which will make you uncompetitive, nor can you worry too much about cost that the service quality is so bad customers are not going to come. So the thumb rule generally in service firms is, moment you cross 80% utilization, things are not good. So generally the thumb rule is 80%, 85%, they don't increase utilization beyond that, because they realize that service becomes not very good. In other words, what is this suggesting? It is suggesting that in business we need to make a trade-off between what is called effectiveness and efficiency. If you want to be very efficient, you cannot afford to be effective. Look at this example, 100% utilization, very low cost of operation, all those are efficient, but it is poor service, therefore it is not effective. So let us put all these thoughts together. So you have 2 axes here. The expected cost is on the y-axis, the level of service is on the x-axis. That is a question we are asking given all this discussion. So this curve nicely summarizes how the costs behave in real life, where you have uncertain process times and uncertain arrival rates or demand. Now this curve talks about this curve that is sloping down talks about the waiting costs. So as the level of service increases, the waiting cost will come down, because you tend to be getting more and more effective. That is what it means. As the level of services comes down, waiting costs will increase. Now this other curve that you see here is the cost of service. So what is interesting is, if you try to do a good job of reducing the waiting cost, you will find your cost of service will go up, and vice versa. So if you take these 2 costs together, this is the third curve, which is the total cost. So, essentially we are looking for this point now. Essentially, in the case of uncertainty, when we make capacity decisions, we are asking how do we locate this particular point, which is a trade off between the cost of service and the cost of waiting. You want to operate in a way where you are efficient, which is acceptable limits, and effectiveness, which creates a certain kind of delight in the minds of the customers. So, this is the another dimension of capacity analysis involving uncertainties that we need to keep in mind when we address some of the capacity problems in our work settings.